Root cause analysis, RCA. Definition of root cause analysis, RCA. Root cause analysis, RCA, is a structured process that uncovers the physical, human, and latent causes of any undesirable event in the workplace. Can be single or multidiscipline cases, small or large cases. Some other definitions: failure cause, the physical or chemical processes, design defects, quality defects, part misapplication, or other processes that are the basic reason for failure, or that initiate the physical process by which deterioration proceeds to failure. The circumstances during design, manufacture, or operation that have led to a failure. Failure effect. The consequences of failure mode has on the operation, function, or status of an item. Failure, the termination of its ability to perform a required function. Failure mode, the effect by which a failure is observed on the failed item. Root cause, RCA, indispensable component of proactive and reliability-centered maintenance. Uses advanced investigative techniques, apply correctives, eliminates early life failures, extends equipment lifetime, minimizes maintenance. Traditional maintenance strategies tend to neglect something important: identification and correction of the underlying problem. A root cause analysis will disclose why the incident, failure, or breakdown occurred, how future failures can be eliminated by changes to procedures, changes to operation, training of staff, design modifications, verification that new or rebuilt equipment is free of defects which may shorten life, repair and reinstallation is performed to acceptance standards, identification of any factors adversely affecting service life and implementation of mitigating actions, improved availability uptime and increased production, reactive, periodic, predictive maintenance, and condition monitoring, proactive maintenance strategies RCFA. Era of maintenance strategies. Reactive maintenance, run the equipment until breakdown, overhaul and repair, extensive unplanned downtime and recurrent repair. Periodic maintenance, scheduled calendar or interval-based maintenance, expensive components exchanged even without signs of wear or degradation, unexpected failures with incorrect schedules and component change-out. Predictive maintenance by condition monitoring. Apply technologies to measure the condition of machines, predict when corrective action should be performed before extensive damage to the machinery occurs. Short and long-term benefits of proactive maintenance strategies involving RCFA. Optimization of service conditions, increased production, reduced downtime, reduced cost of maintenance, increased safety. Experience and statistical data, MMS database, information on equipment design and service conditions, failure statistics for example, MTBF, description of service failures, approach and methods for failure investigation, consequences of failure, downtime, pollution and spillage, secondary damages, causes of failures. Recommendations and remedial actions. Methods and analytical tools to identify the causes of failure or breakdown, review background data, loss causation model and RCA methods and working process. Detailed analyses of failed parts, components, analyze service conditions, utilize experience data from databases or other sources, laboratory investigation. The loss causation model, lack of control, inadequate system, inadequate standards, inadequate compliance to standards, basic causes, personal factors, job and system factors, immediate causes, substandard acts, substandard conditions, incident, inadequate controlled event. Loss, unintended harm or damage. Data collection, interviews, documents, paper, evidence. Parts and component evidence. Interviewing considerations, where to interview, who to interview, condition of people at the scene, how to handle multiple witnesses, how to handle after the incident, how to work with teams. Investigation techniques, a number of named techniques that are commonly used within RCA, step method, FMEA, bow tie, event tree, failure tree, interview, fishbone, YY. The techniques have strength and weaknesses depending on the situation. Methods for RCA, content, data collection, interviews, paper and technical evidence, methods for RCA. Step, FMEA, FTA. Step 1, register equipment incidents. Step 2, trigger mechanism for RCA. Step 3, appoint the RCA team, minor RCAs, run within a department, using the procedure, larger RCAs, leader, appointed by the plant manager, facilitator, reliability engineer. Disciplines or specialists at specific plant, optional to involve, disciplines from other sister plants, HQ engineering support and technical staff, vendor, failure laboratories, other third parties, specialist. Step 4. The root cause analysis, the main RCA reports. 1. Description of the incidents. An incident is the events that precedes the loss or potential toss. This section should include a description of what happened. Include all aspects related to the incidents, like outage time, cost of repair, people involved, tools in use, operational status, weather conditions, etc. 2. Immediate causes. The immediate roots of an incident are the circumstances that immediately preceded the contact and can usually be seen or sensed. For example, if the incident is an oil spill, the immediate cause could be a broken sealing. The immediate causes often are the same as the failure codes registered in Maximo. 3. Basic causes. Basic causes are the real causes behind the immediate causes. The reasons why the substandard acts and conditions occurred, the factors that, when identified, permit meaningful management control. In case of an oil spill caused by a broken sealing, the basic causes could be that the sealing used was of wrong type, it had a design failure, or it might be installed wrong. 4. Lack of control. Lack of control means insufficient oversight of the activities from design to planning and operation. Control is achieved through standards and procedures for operation, maintenance and acquisition, and follow-up of these. If an oil spill has occurred because of wrong installation of a sealing, the lack of control could be related to inadequate procedures for checking after maintenance. Methods for RCA, step, sequential time event plotting, FMEA, failure mode effect analysis, FTA, fault tree, common sense, engineering, and operational experience. Fault tree. What is a fault tree? Identifies causes for an assumed failure. Top event, a logical structure linking causes and effects. Deductive method, suitable for potential risks, suitable for failure events. Which one to use? Step, for complex events with many actors, when time sequence is important, FMEA, getting overview of all potential failure, easy to use, FTA, identifies structure between many different failure causes. Non-homogeneous case, different disciplines. Detailed analyses of failed parts and components. Typical examples of systems and equipment that can be analyzed, electrical generators, heat exchangers, subsea equipment, valves, control systems, pumps, fire and gas detectors, sensors and measuring devices, components of gas turbines, compressors, cranes and lifting equipment, well and downhole drilling equipment. Proactive maintenance through root cause failure analysis, RCFA. Maintenance strategy based on systematic and detailed knowledge of the causes of failure and breakdown, systematic removal of failure sources, prevent repetitive problems, minimize maintenance downtime, extend equipment life. RCFA evaluates factors affecting service performance such as materials and corrosion, and environment, changes in operational conditions, stresses and strains, presence of defects and their origin, nature and consequences. Design, welding procedures, and material weldability. The most common causes of service failures or breakdown: incorrect operation, poorly performed or inadequate maintenance, incorrect installation and bad workmanship, incorrect repair introducing new defects, poor quality manufacture leading to substandard components, poor design. Examples of problems disclosed by the laboratory investigation as part of the RCFA: gears, incorrect material, incorrect heat treatment, incorrect design, incorrect assembly, corrosion, lubricating problems, vibration, incorrect surface treatment, geometric imperfection, incorrect operation, fatigue or overloading. Examples of problems disclosed by the laboratory investigation as part of the RCFA: bolts, indoor material, poor design, manufacturing defects, incorrect assembly, corrosion, vibration, poor or incorrect surface treatment, geometric imperfections, incorrect application, incorrect torque or overloading. Examples of problems disclosed by the laboratory investigation as part of the RCFA: ball and roller bearing, poor design, manufacturing defects, poor alignment and balance, seal failure, electrical discharge, arcing, overload, inadequate lubrication, vibration, contamination, fretting, corrosion. Root cause failure analysis disclosed failure of main bearing, heavily worn raceway, cracking of case-hardened surface, plastic deformation of sealing groove. The main cause of failure was overloading of the bearing. Actions and recommendation: reanalysis by FEM and redesign. Typical components that can be analyzed: gears, bearings, bolted connections, shafts, impellers, pistons and cylinders, motor rotors, and stators. Pressurized components and pressure vessels, steel wire ropes, hydraulic components, welded joints. Sequentially time event plotting, capturing of the sequential events leading up to an accident. Can be a simple timeline, investigation of larger incidents and accidents where the time sequence is important, handles complex events with several actors, several events in parallel, a longer time horizon, should include both equipment, control, and human actions. FMEA, cause-consequence, failure mode and effects analysis, overview of failure mode and effect for a complex machinery and operation, getting an overview of all potential failure causes and effects at an initial stage of an investigation. Requires detailed knowledge of the problem in question, easy to use for both events and for potential losses where risk is included, not good at handling time series. Technical and working process, analysis goal, system. Definition, system boundaries, operational state, limitations, assumptions, system description, documentation, division into subsystems, for example. Functional decomposition, analysis planning, find expert team, plan expert sessions, when, what, who, make documentation available, expert sessions, guided brainstorming to collect information, fill in forms, likely causes, exclusion, final causes, evidence finding, inspections, failure analysis, interview,